This is part 2 of 2 of my lesson on exponent laws for the Math 10 curriculum. So this part is dealing only with the examples. Example 1, simplify by writing as a single power 0.8 to the negative 2 times 0.8 to the 7. So what we have here is a product of common bases, so we add the exponents. Negative 2 plus 7 is positive 5, so 0.8 to the positive 5. Note also, if you forget the exponent law, you could expand and cancel, but I won't do this on the rest of the examples because they get relatively complicated. You're going to want to remember your exponent laws or use a simple example like I showed you in the lesson part of this lesson, part 1. To figure out what the exponent law is if you have a common base between two exponents that you're multiplying. So in just this one, I'll show you it expanded and canceled. So 0.8 to the negative 2 is, remember, a negative exponent. You want to replace that with 1 divided by, and then rewrite 0.8 to the 2 on the bottom. And then we have 0.8 to the 7, and I'll just write the 1 on the bottom there to make it clear. We multiply our numerators, multiply our denominators. So on the top we're expanding now, 0.8 7 times, 1, 2, 3, 4, 5, 6, 7, and on the bottom 0.8 2 times. You cancel 2 of these 0.8s on the bottom with 2 of the 0.8s on the top, and you're left with 1, 2, 3, 4, 5 0.8s on the top. So you can see you end up with 0.8 to the 5 in the numerator, so again you figure out the law. Because you end up with 5 in the numerator, you started with negative 2 and 7. So, you see that you had to add those. But as mentioned, as shown before, figure out the law with a simple example to save time, then apply the law to the actual question. So in this case, you could have done, say, 0.8 to the 1 and 0.8 to the negative 3 or something. Use smaller exponents. And then you can still figure out the law and then just apply it to your question. It's a very powerful tool to figure out quickly what the law is on your test in case they don't give them to you. If you haven't memorized them, don't worry, you can figure it out pretty quickly. So we're going to look at more complicated examples now. Example 2, simplify by writing as a single power. We have negative 5/3 to the 4 to the negative 2 multiplied by negative 5/3 to the 2 to the negative 3. So this looks pretty complicating, but it's not that bad. You want to see fairly quickly that this negative 5/3 and this negative 5/3 are the same thing. So in your mind you're thinking, okay, there is a common base that we'll use somewhere. In this case, I would say it's simplest to apply the power exponent laws first. You want to leave the negative 5/3 alone. We're just simplifying this. So you don't want to apply that 4 to the 5 and the 4 to the 3 on the inside here. You just want to leave this as a common base. It says a single power. It doesn't say, so you can keep a power in here. So let's apply each of these exponents to the other exponents first. And how do we do that? We multiply each of these exponents. So 4 times negative 2 is negative 8, and 2 times negative 3 is negative 6. We still are left with our negative 5/3s, but those are common bases. So what do we do? Even though this looks more complicated, those are still the same thing. Remember, those are just the same thing. They are a common base. So what do we do with the exponents? I am hoping you're saying we add them, and that's correct. So negative 8 plus negative 6 is just negative 14. Important note here, responses cannot be given with a negative exponent. So that was a big reason why we did that negative exponents and reciprocals lesson. We can actually just rewrite this as negative 3/5 to the 14th. So we take the reciprocal of here, nothing happens with this sign here, but as soon as we take the reciprocal of this, then our sign switches here. And that's basically how we so our sign switch from negative to positive. That's what we want to do. So this is our final answer. Remember, when you get rid of this, it's 1 divided by, and then this to the 14. But when it's 1 divided by, basically you're taking the reciprocal. So if it's already a fraction and you take the reciprocal, then you've done the same thing. Now I'll prove that to you quickly here. Look at my cursor, negative 5 over 3 to the negative 14 is what we had. Let's write 1 over, and then negative 5 over 3 to the 14 on the bottom. And then, remember, 1 divided by some fraction is the same as 1 multiplied by the reciprocal of that fraction. So we have 1 multiplied by not negative 5 over 3, but negative 3 over 5 to the 14. And then, of course, 1 times this is just going to be that itself. So negative 3 over 5 to the 14. So I just quickly proved here that using your 1 over rule, that will just end up with taking the reciprocal of the fraction anyway. So remember that. If you don't remember that, you can do this every time. You won't need to do, I guess, too many of these questions, but you might as well remember this. You'll need to do enough of these questions. Example 3, simplify by writing as a single power. We have 2.2 to the 2, or 2.2 squared, divided by 2.2 to the 5 times 2.2 to the negative 8. So when I look at this, the first thing I want to do is simplify what I can. I see common bases everywhere, but it'll be easiest, it seems, to simplify the bottom first. Common bases multiplying, so you'll add those exponents, and then we'll use a quotient law to write it as a single power. So simplify denominator with product law, as I mentioned. You'll get 5 plus minus 8, so 5 minus 8 is minus 3. Now simplify with the quotient law. You're going to do 2 minus minus 3. So 2 minus minus 3. Please do use brackets here to keep things clear. I highly recommend just writing this. It doesn't take you long, but write as many of the steps as is reasonable. I know you can do this in your head. Of course, I can do this in my head, but it makes it very easy for yourself to check your questions on your test. You don't want to make a mistake here and then not be able to check it easily. So when you lay it out clearly for yourself, it's not only for the teacher to see your work, it's for you to see yourself checking your work. So 2 minus minus 3 is the same as 2 plus 3, and you get 5. Example 4, simplify by writing as a single power. Okay, so we're getting more complicated here. So this is kind of similar to the last question, except now we've stuck a squared on the outside of this entire thing. So let's work our way out. It's typically easiest to work from inside out when simplifying, so we'll simplify this top first here, and then we'll simplify the inside, and then finally we'll apply the square to the inside. So use the product law on the numerator inside the brackets. So we have a common base everywhere here, a half. Always check that you have that common base, otherwise you cannot use any exponent laws. So what's our product law? It's adding our exponents. I've been nice to you here and giving you exponents all with a common denominator already. We'll see an example where you need to get to a common denominator, but that's back to elementary school math. So negative 3 over 5 plus 9 over 5 is just a 6 over 5. You just add those numerators when you have that common denominator. Now simplify the inside of the brackets here with the quotient law. So 6 over 5 minus 1 over 5. 6 over 5 minus 1 over 5. That's the quotient law. And that'll be, just look at my cursor here. 6 minus 1 is 6 plus 1 is 7 over 5. And then one final step. We want to apply the square on the outside here to this exponent here. How do we do that? We need to multiply those two together. If you forgot how to do that, look at the part 1 of this lesson. So what's 7 over 5 multiplied by 2? Well, that's the same thing as 7 over 5 multiplied by 2 divided by 1. And you multiply the numerators, multiply the denominators when you multiply fractions. So it's just 7 times 2 is 14 on the top, and 5 times the 1 is a 5 on the bottom. And finally, we're done this question. So these can look pretty complicated, but once you break it down into, okay, narrow your focus on, okay, look for those common bases, then use the basic exponent laws, and it's not too bad. It was what, 1, 2, 3, 4 steps here. Example 5. Simplify by writing as a single power. C to the 5, d to the negative 7 times c to the negative 8, d to the 9. So everything is multiplied by everything else here. You can kind of ignore the brackets. So use the product law for powers with common bases. You can see we have 2 c's and 2 d's here. So for the c's, you add those exponents. 5 plus negative 8 is negative 3. Negative 7 plus 9 is a positive 2. And remember, you cannot give an answer with any negative exponents. So we need to rewrite that c to the negative 3 as 1 over, 1 divided by. That's how we get rid of our negative exponent. And then rewrite everything else on the bottom, the c to the 3. And then I have put a 1 underneath my d squared to make it obvious how we're multiplying this together, these two fractions. 1 times d squared is a d squared on the top. C cubed times 1 is a c cubed on the bottom. And that is our answer. Example 6. Simplify by writing as a single power. 5x squared y to the negative 3 divided by 15x to the negative 4 y cubed. So I believe this is the last example here. You can see the main thing I've added in here are just some numbers. So we'll deal with the numbers separately, we'll deal with these x's separately, and the y's separately. So dealing with 5 over 15, greatest common factor, a GCF that goes into both of those is a 5. So we divide a 5 into both the top and the bottom of this fraction, and then we don't actually change it, we just do that so that we can reduce our 5 on the top to a 1 and a 15 on the bottom to a 3. Now I haven't done anything with my variables yet, so now we'll deal with those, and we're just going to have to use the quotient law. So look at my cursor here. We ended up with an x to the 6. That was because we did x to the 2 minus 4. So 2 plus 4 is a 6. And we had y to the negative 3 minus that 3 here. So minus 3 is a minus 6. We're left with on the top there. Again, you could have done here, if you start with the one that has more, so a higher positive value, so of course that's the bottom. So that's y to the 3 minus 3, and you would end up with a y to the 6 on the bottom. So whatever you start with, that's what you'll end up with. And you'll see that in this step here, since we went negative 3 minus 3 and then we wrote our y to the negative 6 on the top, we can't have negative exponents again. So we rewrite that as 1 divided by y to the 6. So that flips the y to the 6 on the bottom. So that is our final answer there. And I just wanted to point out at this step, you could have done the y to the 3 minus 3 and already gotten y to the 6 on the bottom. So that would have saved you a step. Feel free to do that. I probably would have done that if I was doing the test. Okay, we have another example here. Example 7. Simplify by writing, I remember now there are 8 examples. Simplify by writing as a single power. So this is similar to an example a couple examples ago, or rather, let's see. Yeah, it's similar to example 5, right? But what's the difference? We have fractions in our exponents. So we still use product laws for powers with common bases. Now, this is what I alluded to earlier. Remember, common denominators are required for adding, subtracting fractions. So you had c to the half, c to the negative 1/4, so it's a half plus minus 1 over 4, so a half minus 1 over 4. But you need a common denominator here. So I changed my half into 2/4, multiplied the top and bottom by 2 to get to a common denominator. And then for the d's, there is already a common denominator, so it's just 3 over 5 plus 6 over 5 here, 3 over 5 plus 6 over 5. And now it's just adding or subtracting. So we have 2 minus 1 is a 1 over our common denominator. And 3 plus 6 is 9 over that common denominator of 5. Example 8, simplify by writing as a single power. So you can tell this is one of the more complicated examples, and it is our last example. So you can see we have numbers here. We're going to use some quotient law here and an exponent law with that half up there. Simplify what you can inside the brackets. Let's work our way out. So that would only be the a's here. Nothing else is really the same. You can't even reduce that 16 and 49. You can't put a 2 into both. 49 is an odd number. But this half will be a square root, which we'll be able to apply to that 16 and 49. So just simplifying what we can here, a to the 7 on the top, a on the bottom. That we're left with an a to the 6 on the top. Everything else stayed the same. And we can't simplify anything else in the brackets, so now we're going to apply this exponent. And how do we do that? We apply it to every single thing on the inside of the brackets. So 16 to the half, a to the 6 to the half, and that will be multiplying those two. So 6 times a half is just a 3. 49 to the half, remember it applies to everything in the denominator as well. And b to the negative 1/3 to the half. So multiplying those, you have negative 1 times 1 on the top is a negative 1, and 3 times 2 in the denominators is a 6. So feel free to pause right now. As with all my lessons, of course, you'll want to pause if you want to take in anything that I've written down, or typed down rather, especially on a more complicated example like this. See how I went from everywhere here to down here. Now, what is the exponent half in radical form? That's just a square root. So, the square root of 16 is a 4. Our a cubed didn't change. The square root of 49 is just a 7. And, again, we don't want to leave negative exponents anywhere. So, b to the negative 1/6 we can get rid of that negative exponent and take that reciprocal, and that just jumps it to the numerator there. Feel free to prove that to yourself. You could write 1 divided by b to the negative 1/6, and then you would have 1 divided by 1 over b to the positive 1/6, and then you multiply the reciprocal, and so you could prove that to yourself if you wanted. And so finally, we're done all of the examples here.